Okay, in this video we're going to go over the solutions to problems of the week number 4. The first question is asking you to integrate this using the substitution method. So here U should be, well, you had two choices, but the easiest one is U equals to 1 minus x squared. The other choice is you could use U equals to x squared, but this one will make the problem easier. So if U is equals to 1 minus x squared, that means the U is negative 2x dx. So then our integral becomes du over U. You have to take into account that the minus 2 was not there, so this will be minus 1/2. So this will give you minus 1/2 ln of U plus C, which is negative 1/2 ln of 1 minus x squared plus C. Now this is good enough for an answer, but if you use the properties of logs, remember that ln of m to the k, the same thing as k ln m. So you can go from here to here, or from here to here. So we use that. This is the same thing as ln of 1 minus x squared to the negative 1/2 plus c, which is the same thing as 1 over 1 minus x squared, the square root, and ln of the whole thing plus c. Okay, now let's do a trig substitution. So let's start with u is equals to, actually that's not how you start. You say, okay, x is equals to sine theta. So that means the x is equals to cosine theta d theta, and this implies that 1 minus x squared is 1 minus sine squared theta, which is the same thing as cosine squared theta, using the identity that cosine squared plus sine squared is equals to 1. So then if we do that substitution, our integral, which is this, is the same thing as x, which is sine theta, over 1 minus x squared, which is cosine squared theta, times dx, which is cosine theta d theta. Well, here this cancels one of this, and you end up with the integral of sine theta over cosine theta. If we do a u substitution here, u is cosine theta, du is minus sine theta. So therefore this is the same thing as negative the integral of du over u, which again is negative ln u plus c, which is negative ln by u, remember, is equals to cosine theta plus c. We need to finish the problem by changing everything in terms of x. Remember, we start with sine theta from here is equals to x. So this should be x, this should be 1. So then if you use the Pythagorean theorem, this will be 1 minus x squared, the square root. So therefore this is negative ln cosine, but cosine is 1 minus x squared plus c. If we use the same rules from before, this is the same thing as ln of 1 minus x squared to the negative 1 plus c, which will give you the exact same answer that we got in part A. Okay, now let's solve the problem using partial fractions. So first we need this to equals to this. So just factor the denominator. So this implies that you need to solve a equation that looks like this. So this is the partial fractions. Now let's say that x equals to 1. If x is 1, then you end up with 2a plus 0b equals to 1, which implies a has to be 1/2. Now pick x equals to negative 1, so you end up with 0a plus 2b, so you have to be careful here. Remember, 1 minus 1 is 2, and this is equals to negative 1 because we're picking x to be negative 1. So that implies that b is equals to negative 1/2. So then this is the same thing as integrating 1/2 1 minus x plus negative 1/2 over 1 plus x dx. So this is the same thing as 1/2 the integral of this and the x over 1 plus x. If we integrate this, you end up with negative 1/2. You may want to use a U-substitution to get this part. ln 1 minus x minus 1/2 ln of 1 plus x, all of this plus c. Alright, we can factor the minus 1/2, and it will give you ln of 1 minus x plus ln of 1 plus x. And again, if we use the properties of logs, whenever you have a sum, that becomes a multiplication. So this will be 1 minus x, 1 plus x. Okay, you have to multiply this and down. So from here, we end up with negative 1/2 ln 1 minus x squared. The x squared is actually inside. So 1 minus x squared. Everything plus c, which is the same answer as the other problems that you simplify. Even if you get this far, if this was the method, this is good enough. Okay, so finally, answer the following and explain using specific examples. Any integral can be solved using partial fractions, or any integral that can be solved using partial fractions can always be solved using trigonometric substitution. Well, in theory, yes, but in practice, it's not necessarily the case. But the answer is yes, but the problem can be very, very messy. Now, the one that you can definitely say no is the second one. Any problem using trig substitution can always be solved using partial fractions. This one is a no, and this is the most clear example. Let's say you have something like this. Trig substitution will work, but partial fractions won't work. So partial fractions won't work. Okay. Now again, part A is yes in quotation marks, but it can be very messy. So it's probably not recommended unless it looks nice, whatever that means. So if you say here, no, you are also technically correct, but the only one that is a definitely no is this one. That's it.